to mundo fine, night train to the end. Running hard and running fast to meet my future and away from my past. Taking the gamble that cannot last. Night train to the end.
This is the hello, greetings. This is the Frater SH Night Show, and our article is U.S. Airman witnesses UFO and shadow person while guarding nukes. Reister had been a former USAF nuclear weapons technician, has spoken out about his experiences. Reister, many of those stationed at such facilities, however, he reported a number of strange sightings and experiences during his time there that even to this day he has been unable to explain. In one instance, Reister encountered a strange object hovering above some nearby trees. I noticed a lighter orb hovering around the top of the tree line. I thought it was just a star at the time, but as I continued surveilling the area, the light orb shot above the tree tops and hung there for some time. He told the Liberation Times, maybe it was a satellite, I thought. But then it bounced a little in the sky and then shot to the left, then shot 90 degrees straight up and disappeared. Even stranger was that he experienced during the summer of 2006 was what he experienced. While working on the night shift, he recalled hearing the footsteps of someone without any shoes. I saw what I can only describe as a black mass in the shape of a person standing at 6 feet tall. He said not really a shadow, but something that was slightly blurry and didn't reflect any light. To this day, no explanation for either of the phenomena he encountered has been forthcoming. Now the next article. Okay, study nixes Mars life and meteorite found in Antarctica, a 4 billion old meteorite from Mars that caused a splash here on Earth decades ago, contains no evidence of ancient primitive Martian life after all, scientists reported Thursday. In 1996, a NASA-led team announced that organic compounds in the rock appeared to have been left by living creatures. Other scientists were skeptical, and researchers chipped away at that premise over the decades, most recently by a team led by the Carnegie Institute for Science's Andrew Steele. Tiny samples of the meteorite show that the carbon-rich compounds are actually the result of water, most likely salty or briny water, flown over the rock for a prolonged period of time. Steele said the findings appear in the journal Science. During Mars' wet and early past, at least 2 impacts occurred near the rock, heating the planet's surrounding surface before a third impact bounced it off the red planet and into space millions of years ago. A 4-pound rock was found in Antarctica in 1984. Groundwater moving through the cracks in the rock while it was still on Mars formed the tiny globes of carbon that was present. According to researchers, the same thing can happen on Earth and can explain the presence of methane in Mars' atmosphere, they said. The 2 scientists who took part in the original study took issue with these latest findings, calling them disappointing. In a shared email, they said that they stand by their 1996 observations. While the data presented incrementally adds to our knowledge of the meteorite, the interpretation is hardly novel, nor is it supported by the research, wrote Kathy Thomas, Caperta, Simon Clement of Astronomical Researches at NASA's Johnson Space Center in Houston. Unsupported speculation does nothing to resolve the conundrum surrounding the origin of organic matter in the meteorite, they add. According to Steele, advances in technology made this team's new findings possible. He commended the measurements by the original researchers and noted that their life-claiming hypothesis was a reasonable interpretation. At the time, he said that he and his team, which included NASA's German and British scientists, took care to present their results for what they are. And this is a very exciting discovery about Mars and not a study to disprove the original premise. This finding is huge for our understanding for how life started on the planet and helps to refine the techniques we need to find life elsewhere on Mars or Enceladus and Europa. Still said in an email referring to Saturn and Jupiter's moons with subsurface oceans. The only way to prove whether Mars ever had or still has microbial life, according to Steele, is to bring samples to Earth for analysis. NASA's Perseverance Mars rover already has collected 6 samples to return to Earth in a decade or so. 3 dozen samples are desired. Millions of years after drifting through space, a meteorite landed on an ice field in Antarctica thousands of years ago. The small gray-green fragment got its name, Allen Hills A4001, from the hills where it was found. Just this week, a piece of the meteorite was used as a first-of-its-kind experiment aboard the International Space Station. A mini scanning electron microscope examined the sample. Thomas Caperta operated it remotely from Houston. Researchers hope to use the microscope to analyze geologic samples in space. On the moon one day, for example, the debris that could ruin station equipment or endanger astronauts. This last article is we don't know why, but being in blood causes us to destroy our blood. Space isn't easy on humans. Some aspects are avoidable. The vacuum, of course, and the cold, as well as some of the radiation. Astronauts can also lose bone density, thanks to a lack of gravity. NASA has even created a fun acronym for the issue RIDGE, which stands for Space Radiation, Isolation, and Confinement, Distance from Earth, Gravity Fields, and Hostile Enclosed Environments. New research adds to the worries by describing how being in space destroys our blood. For rather something about space, and we don't know what just yet, causes the human body to perform hemolysis at a higher rate than back on Earth. This phenomenon is called space anemia. It has been well studied and is part of a suite of problems that astronauts face when they come back to terra firma, which is how Guy Trudell, one of the paper's authors and a specialist in physical medicine and rehabilitation at Ottawa Hospital, got involved. When the astronauts return from space, they're very much like the patients we admit in rehab, he told ours. Space anemia has been viewed as an adaptation to shifting fluids in the astronauts' upper bodies. When they first arrive in space, they rapidly lose 10% of the liquid in their blood vessels, and it was expected that their bodies destroyed a matching 10% of red blood cells to get things back into balance. People also suspected that things went back to normal after 10 days. Trudell and his team, however, found that the hemolysis was a primary response to being in space. Our results were a bit of a surprise, he said. Space, no one can hear you breathe in a can. To study space anemia, Trudell worked with 14 astronauts on a 16-month stint on the International Space Station. The astronauts brought specialized canisters and exhaled into them at 4 set intervals, at 5 days, 12 days, 3 months, and just before heading home at 6 months. Then, with their primary mission over, they brought the canisters back down to Earth, breath and all. Back in the lab, the researchers looked at the astronauts' breath using a high-resolution gas chromatograph, which measures the amount of carbon monoxide they were produced in after different amounts of time in space. According to Trudell, carbon monoxide is created each time a red blood cell is hemolyzed in the body. This isn't a perfect connection, as other bodily processes can result in the production of carbon monoxide, like some functions of muscles and livers. However, Trudell noted that an estimated 85% of carbon dioxide produced by a human comes from hemolysis. The team's results showed that in space, the astronauts' bodies destroyed around 3 million red blood cells every second. This is a 54% higher than what happens in human bodies on Earth, where the rate is 2 million every second. In space, the human body loses fluid, so even though an astronaut's body ends up with fewer red blood cells, the concentration stays at an acceptable level. But when a human returns to Earth, their bodies regain their fluid to cope with the increase in gravity, and space anemia kicks in. You need more fluid in your blood vessels, and that will dilute your red blood cells, he said. After the astronauts returned on their voyage, 5 out of 13 had blood drawn upon landing, and they were still clinically anemic. After 3 or 4 months, the red blood cell count continued to grow. However, Trudell's team performed the same test a year later and found that the red blood cell destruction was still 30% higher in the astronauts. According to the research, the longer the astronauts stay in space, the longer space anemia will plague them on solid land. Trudell's team isn't sure exactly why being in space would cause the human body to destroy blood cells at this faster rate. There are some potential culprits, however. Hemolysis can occur in 4 different parts of the body: the bone marrow, where red blood cells are made, the blood vessels, the liver, and or the spleen. From this list, Trudell suspects that the bone marrow or the spleen are the most likely problem areas, and his team has plans to investigate the issue further in the future. What causes the anemia is hemolysis, but what causes the hemolysis is the next step, he said. It's also uncertain how long a person in space can just continue to destroy 54% more red blood cells than their earthbound kin. You don't have data beyond 6 months. There's a knowledge gap for longer missions, for 1-year missions or missions to the moon or Mars or other bodies, he said. Considering the looming possibility or reality, if you're a billionaire of a looming possibility of space tourism, Trudell's research could pose a warning for some who would be spacefarers. People with heart problems, angina, abnormal hemoglobin levels, or a propensity for blood clots might be at risk of complications out in the void, he said. The work may also help us learn about space injuries. A body's ability to heal a cut might be affected by the shift in red blood cells. According to the length of time the space anemia can stick around. This research has also have implications for very active astronauts. That's another knowledge gap, the effect of repeated missions, he said. And that's all for the show for today. Thank you.